Good afternoon. On page 481, we're doing lesson 94 today, and it's more volume of solids by rotating about different axes. If you look at 94.1, it says let R be the region bounded by the coordinate axes, so the coordinate axes, and the lines y equals x, so that's this, and x equals 5, so 1, 2, 3, 4, 5. Okay, so it says find the volume of the solid generated by rotating R about the line x equals 5. So it's not going around the x, it's not going around the y, it's going around this line right here. So if you'll picture bringing this corner all the way around over here, then what kind of a shape would that be? It's going to go round and around that x equals 5 line. It's a cone, isn't it? And the height of the cone, if this line is y equals x and this is 5, then the y value would also be 5, wouldn't it? So we can do this without calculus, and we'll do it without calculus just so we have a value that we can check the answer using calculus. So the volume of the cone would be 1/3 the area of the base, and that would be pi times the radius would be 5 squared times the height, which is also 5. So that's 25 times 5, which is 125 pi over 3. So that's the answer we're shooting for using calculus. All right. So we're rotating it this way. So our slices are going to be like this, which means that this is dy, isn't it? So all the variables have to be put in terms of y. Now if we look at this and write it in terms of x, it doesn't really matter because of this right here. Y is equal to x. Y equals x. So when we can just interchange x and y, it doesn't matter. So let's see. If we integrate with dy, we're going to integrate from here up to here, correct? And it'll be this line right here. So the volume will be equal to the integral from 0 to 5 of pi times the radius, which would be this distance in here, from here to here. So if this is y, then this radius would be this point, any point here. I mean, remember these slices are going to move. We're going to get slices all the way, but the height will always be 5 minus whatever the y value is. So that's the radius. And then times the width of the slice gives us the volume. Okay, so if we go to integrate this, remember we have to use FOIL and multiply it out. I'm going to pull that pi out in front. So that's 25 minus 10y plus y squared dy. Now integrate. So it'll be v equals pi times, that'll be 25y minus 10y squared over 2, which is 5y squared, plus y cubed over 3, and that's going to be evaluated from 0 to 5. So what's going to happen when we plug the 0 in here? There's a 0, 0, 0. That's all 0. So all we have to do is plug in the 5. So that'll be 25 times 5 minus 5 times 5 squared plus 5 cubed over 3. All right, so that's 125. That's 25 times 5 is 125. And then 5 cubed is 125 over 3. So it's going to be 125 pi over 3. So it's the same no matter which way we do it. All right, let's try a few more of these. One on page 482. It says region R is bounded by y equals x cubed. Okay, so x cubed is that curve that goes like this. The x-axis, okay, this, and the line x equals 2. All right, so this region right here, this curve, this line, and this line. Use the disk method to write an integral that represents the volume of the solid form by rotating the region about the line x equals 2. So it's going to come around here. And it wants us to use the disk method. So using the disk method, they're all going to be circles, aren't they? We're just going to add a whole bunch of circles up. So let's see, we need to find out what point this is up here where these two intersect. So we have y equals x cubed, and we have x is equal to 2, so y would be equal to 8 right here. So if we integrate from y equals 0 to y equals 8, and we don't have to work this, it just says, oh, I guess we can. It just says to, oh, and then it says evaluate it, sorry. Okay, so volume equals, what's the radius of one disk if we're going from y equals 0 to y equals 8? Now remember the disks are like this, so that's dy. So we know we have to have y's in the as the variable. Well, it would be, the radius at any point would be 2 minus whatever the x value is, right? If we come out here, that'll determine what the radius is. Now we can write it like this. But ultimately, we can't solve it like this because we can't have a dy and an x. But we know that y is equal to x cubed, so x, right here, solving this, x would be equal to the cube root of y, right? So I can plug cube root of y in here for x. So volume will be the integral from 0 to 8 pi, I can pull that out in front, of 2 minus, we could write it as the cube root of y, or we could write it as y to the 1/3, and then that's squared dy. All right, so there's the integral. Now it says to evaluate it. So we have to use FOIL to multiply this out. So that's v equals pi integral from 0 to 8 of 4 minus 4 y to the 1/3 plus y to the 2/3. And all of that times dy. Okay, now then, integrate that. So it'll be pi times 4y minus, let's see, the 1/3 plus 1 would be 4/3 over 4/3. So then 4 times 3/4 would be 3y to the 4/3. And then plus 2/3 plus 1 would be 5/3, so this would be 3/5 y to the 5/3, and that's evaluated from 0 to 8. Okay, well, again, if we plug in 0 here, that'll be 0, 0, and 0, so we don't have to mess with the 0. It's just going to be pi times 4 times 8 would be 32, minus, right here, cube root of 8 is 2, to the 4th power would be 16. 16 times 3 would be minus 48, plus, again, the cube root of 8 is 2, to the 5th is 32. And 32 times 3/5 would be 96 fifths, if I did that right. So if we get a common denominator and add these, that would be pi. And this would be 5 times 32, so that would be 10/160. Minus 5 times 8 is 40. 240 plus 96, all of that over 5. So what does that come out to? Wow. $160 plus 96 would be 256, and 256 minus 240 would be 16 pi over 5. Okay. Now both of those were using the disk method. And now we're going to move on to the next one, which is also using the disk method. It says, region R is completely enclosed by x equals y squared. Okay, that's a parabola, but it opens weird. It's not the parabolas that we usually work with. X equals y squared is the parabola that does this. And y equals 2, so actually would be, I'll just say that 1, 2, 3, we'll say this is 2 instead. Completely enclosed by that and the y-axis, so it's this area right here. Okay. The region is revolved about the line y equals 2, so it's coming up this way, all right? So if we draw the discs, because this thing is going to go like this, if we draw the disc, now they're going to be dx instead of dy this time. Okay, all right, so using the disk method, we'll integrate from, if we're going to use, if this has to be dx, we're going to have to integrate this way on the x-axis. So if this is 2, remember this equation is x equals y squared. And if y is 2, then x would be equal to 4 right here. Okay, so that's x equals 4. So then the integral will be set up from x equals 0 to x equals 4. And then pi. Okay, now our discs, the radius would be, at any point, this would be y. So then the radius would be 2 minus y. Because if we come up y, then this radius of the disk would be 2 minus y. So that would be 2 minus y, quantity squared, but it's dx, because the width of that disk is dx. So now we go back up here, and we have to solve this one for y. So y would be equal to the square root of x, wouldn't it? Or x to the 1/2. So v equals pi. Now we're changing it to x, so we don't need to write x equals. That'll be 0 to 4. 2 minus x to the 1/2, quantity squared, dx. It says use the disk method to write an integral in terms of x whose value equals the volume of the solid generated. So that's what we did. We wrote the integral, we're done. They don't ask us to evaluate it. All right, next. Page 483, 94.4. Hang in there, guys. We only have a couple more of these. It says the region defined in example 94.3, that's the one we just did. So it was that parabola shaped thing that went like that, is rotated about the line y equals 3. So remember, this was 2. So now there's a line at y equals 3. It's going to get rotated about that. So remember, this thing is going to actually, it'll be up here, but it'll be like that. I can't show it because it's on the top of the page. But so what happens is, here's the solid region. And then this will be the solid region up here also. But it's coming across this, so what's this in here? What is this? It's a hole, isn't it? So we're going to end up with a washer, something that has a hole in the middle of it. Okay? All right, the discs are still going to be dx. So it's going to be real similar to the last one. But now we're going to integrate from where to where. Got to have dx. So this was 4, remember? That doesn't change. So we're still going to integrate. It's going to be, a washer will be x equals 0 to x equals 4 again. Pi times, remember a washer is the outer radius squared minus the inner radius squared. Okay, so the inner radius is always going to be 1, isn't it? This is just a hole right there. So we can put here minus 1 squared. That doesn't matter. And then remember this is dx. So now we just have to get this radius. Now, instead of it being 2 minus y, it's coming about this line right here. So the radius is going to be, remember that's 3. The radius will be 3 minus y. So this will be 3 minus y quantity squared. Okay, but we can't have x's and y's in an integral. So that equation was x equaled y squared. So y was equal to the square root of x, or x to the 1/2. So we can go back and change this. 0 to 4, I'll pull pi out in front. And this will be 3 minus x to the 1/2 quantity squared minus 1 squared, which is 1, dx. All right. Now I'm just going to go ahead and do this by hand. They put it in the calculator, but it's not that bad. 0 to 4 would be, this would be 9 minus 6x to the 1/2 plus x to the 1, and then minus that 1, dx. And then what 9 minus 1 is 8, right? So that's going to be the integral from 0 to 4 of 8 minus 6x to the 1/2 plus x dx. And now we can integrate it. So be pi times 8y minus x to the 1/2 plus 1 would be 3/2. And then this will be times 2/3. So that'll be 2 times 2, that'll be 4 x to the 3/2, and then plus x squared over 2 evaluated from 0 to 4. There's an x in every one of these, so that 0 is not going to matter, is it? Okay, so we'll have v will be equal to pi times, the square root of 4 is 2, and 2 cubed is 8, so 8 times 4 is 32. And then plus 16 over 2 is 8. Let's see, 8 times 4 is 32 minus, what did I do here? Oh, minus 32. Forgot to put the minus 32 in here. 32 minus 32 plus 8. There we go. So then these cancel out, and we just get v equals 8 pi. All right, one more, page 484. It says, let R be the region bounded by y equals e to the x. Okay, y equals e to the x. E to the 0 would be, it starts at 1 and goes up like this. the x-axis, x equals 1, and x equals 2. Okay, so we're talking about this region right here. A solid revolution is formed when this region is rotated about the line x equals 3. Okay, so that was 1 and 2. So 3. Here's the line that it's going to be rotated about. So again, let's see, what does it say? Use the shell method to write an integral that could be evaluated to find the volume of the solid. So we're just going to write the integral. We're not going to evaluate it. All right, so let's see, using shells, the volume would be 2 pi r times the height, which is y, and then times the little shells are dx. Okay, now this was y equals e to the x, and then we'll have to figure out what the radius is. So the volume is going to be 2 pi is a constant, pull it out in front. We're going to integrate from just this area right here, 1 to 2. Now the radius, what's the radius? Remember, we're coming the radius is from here, this is the starting point, back to here. So if our x is here, then our radius will be 2 minus, excuse me, that's a 3 minus x. So the radius at any time will be 3 minus x. So 2 pi, the radius, and then y is e to the x, and then r dx. Okay, let's see, they went ahead and multiplied it out. They broke it up into 2 integrals. So this one, if we break it up into 2, this would be, you don't have to do this, I'm just going to show you. This would be 2 pi integral 1 to 2 of 3 e to the x minus x e to the x dx. And so what they did was they took this as one integral, and then they took this times this as one integral. So 3 times 2 would be 6 pi, the integral from 1 to 2 of e to the x dx. And then minus the 2 pi comes over here, 2 pi times the integral from 1 to 2 of x e to the x dx.